Vibration Research's June webinar. Today we will be talking about multi-axis testing and highlighting some of the capabilities that VR has with the 10.5 vibration controller. My name is Kevin Van Popering and I will be the presenter today. So let's get started. All right, so what is multi-axis testing? I've got a couple of pictures here. First picture on the left, you may be looking at that and saying, well, that looks like single-axis testing. Yes and no. We'll talk about this particular method of three-axis or multi-axis testing. Take a look at the middle image. That's probably what you're thinking of when you hear multi-axis vibration testing. It's more or less a traditional three-axis shaker system. You've got an actuator vertically and then the X and Y axes with the other two shakers all testing simultaneously. And then on the right is another type of multi-axis test. There are a couple of actuators if you're looking directly on the picture, kind of going back and forth, and then you have another actuator on the right hand side pushing side to side, but again, multiple axes. So, really brief overview of vibration testing in a lab. The most simple and the most common will be on the left here with the uniaxial tests. If you've been in a shaker lab, maybe you have one on site at your facility. Most of those shakers are going to be single axis shakers. They drive one axis at a time. So whether it's mounted vertically or up and down, or you have it rotated to drive a slip plate, but single axis, you can use those single axis shakers to test in multiple axes. We'll show that here coming up. It can be electro-dynamic, servo-hydraulics, some other or hybrid shakers, but most common. And if we go from the left to the right, are the more involved, more difficult, more costly multi-axis tests. And if we see MDOF, or multiple degrees of freedom, can be two. We'll talk about that, like a dual axis system. 3 degrees of freedom, so 3-axis or a tri-axis test, and up to 6 DOF, or 6 degrees of freedom. Multi-axis, I mentioned they're a little bit less common, typically used for a specific purpose, and they are quite a bit more expensive. But again, can be electro-dynamic, servo-hydraulic, we've seen servo-electric, or other, maybe some mix of, or a unique shaker setup. But this is the types of shaker systems we're talking about, and then we'll talk about some of the capabilities we have for control. I mentioned that first image we saw was a single axis test, but you can do some multi-axis testing on there. A couple of images here showing how that would be accomplished. This shaker, if we start left to right, if I have a product where up is not important, so the shaker, the product does not have to be tested in the orientation in which it is used, you can use, in this case, it's just like an L-shaped fixture. So I've got the product mounted. If you look at the X, it's vertically. I'm testing in the X-axis. Y, so I rotate it. And then Z, I rotate the product, and I have a little clamp fixture holding it down. But I'm testing all 3 axes on a single axis shaker. So that might be one method you're testing 3-axis currently. Another method could be simultaneous 3-axis. In essence, I've got 3 products on a cube. So if it's the same profile for each axis, you could do it this way. That's going to be the middle image right here. I've got 1 product, 2 products, 3 products. I run the test, and then I can rotate the products around so it sees each of the 3 axes. But I'm running 3 at one time. Again, this one in the middle requires that they're the same profile. And this is just kind of a fun example, but if you're wondering what axis is Z, what's X, what's Y, make the little finger guns, and then stick your middle finger out, we'll say perpendicular to your pointer finger. Z is up, X is forward, Y is left to right. Something you can use to impress your fellow lab friends. But so single axis, okay, if neither of these is a possibility, your product has to be mounted in the orientation in which it's used. A couple other reasons why you would do 3-axis testing too, but this leads us to the multi-axis testing. And when we're talking like traditional 3-axis testing, you may be wondering why would somebody run these types of tests? They typically are going to be more real world. I have a product out in the field while it's being used. Chances are it's going to be excited in more than one axis at a time. You know, you're getting some in all 3 axes as this product's in use. And you can get a more realistic simulation in the lab. You also might have a product that has a very specific dynamic response, and you don't see that when you're testing in a single axis alone. And you'll notice it does respond differently when excited in all 3 axes simultaneously. So more real world, that's kind of been the push to 3-axis testing recently. But a couple of other reasons that can be beneficial. Big one's going to be shortening test time. So if I have a test spec that's 30 hours per axis, that's 30 in X, 30 in Y, 30 in Z for a total of 90 hours. If I can run X, Y, and Z at the same time, all for 30 hours, it cuts my test time down to a third. So there can be a big time savings involved too. Another use could be if you have a very large test article. I've got a couple of images in future slides, but if I have a test article that's very, very big, I need a massive fixture. It may be too big to be driven by one shaker. So we can do something called a push-pull setup or a push-push setup, but this would be 2 shakers driving the same test article, and we'll talk about some of the capabilities here very shortly. The brief overview, and we've changed the terminology of this recently. Now it's called, we're just calling multiple or multi-loop or loops, and then with or without phase control. Very broad terminology, but this can include anywhere from 2 to 4 shakers, so more than one. And then we can run these loops in phase, we can offset the phase, some pretty unique things that we can do. Next one will be simultaneous 3-axis, so that traditional 3-axis shaker setup that I showed earlier. And then we have a tripod system or a seismic system. Pretty similar to the simultaneous, there's just one tweak or one additional input that we have to fill into the software. So to do multi-axis testing, what is required? What is required is the VR10500 vibration controller. This is our latest and greatest hardware model. It can accommodate up to 512 channels, but it's a 16-channel block on each hardware unit. Up to 256 kilohertz sample rate, and up to 4 loops for control for sine, random shock, and field data replication. And then magnitude and phase control is available in sine and random for all 4 loops. If you're an existing customer that may be using our VR9500, and you're running a seismic system, there was something called a geobox. It was an additional piece of hardware that was required to do the geometry of the tripod table. That has been embedded or integrated into the new VR10500 controller, so that piece of equipment is not needed anymore going forward. I mentioned the 9500 just to be clear. All future development for these multi-loop or multi-axis applications is going to be done for the VR10500, and it's actually been that way for the last couple years. So any Any new capabilities, any multi-axis applications will be done on the VR10500, and it's actually been that way for the last several years. But the legacy hardware, I guess, for lack of a better term, is the 9500. You have up to 128 channels, 200 kilohertz sample rate, up to 4 control loops for random shock and FDR. But it's one drive output per box, and we do not allow for magnitude and phase control between boxes. So that's going to be the big limiting factor on this piece of hardware. So everything I'll talk about from here on out is assuming VR10500. And here is the back of that box on the left. So you've got output number 1, number 2, number 3, number 4. And that fourth output doubles as the COLA output, which is something that you did have on the 9500 as well. And then back of the 9500 we talked about, it's a drive output, and then there's also a COLA output, but you're limited to 1 drive per box on each 9500. With the 105, you're basically purchasing outputs, so a number of outputs. If you've got a dual loop system, it's 2 outputs. And then you'll need to purchase whatever software. So Sine, for example, you'd purchase the Sine package along with 1 output, and then a second output along with Sine again, and now both of these loops are active. So first multi-axis application is dual axis with phase control. This typically would be used with something that, for this example right here, they've got a large missile, and they've got it attached to 2 shaker systems here. And what they're doing is driving the shaker. You'd see this missile. I have a video. We simulated this same test in our lab with a PVC pipe. I'll show that in just a moment. But when it runs in Sine, you're going to see it just go up and down at the same time. You also have the ability to offset the phase of those shakers too. So if you want to induce like a rocking motion in that missile, you could do so, and you can manually enter a phase offset between those 2 shakers. Sine, you can enter a phase value of anywhere from 0 to 180 degrees. By increments of 1, so 1, 2, 3, 4, 5, all the way up to 180 degrees. If you're running a setup like this in shock or random, both outputs will be controlled to maintain a 0-degree phase difference. So they're going to be controlled to output the same thing at the same time. If we look at this missile, you'd see it basically doing the same thing on each end. This image too, whoops. You can see we have the 9500. In older versions of the software, it'd be an output from drive and all output from COLA. The second box here was just used for response. So you can see a bunch of accelerometers mounted on the product. With the VR10500, it's just output 1, output 2 to each one of these amplifiers, which drives each shaker independently. So when we talk about phase, and I'll show this in VibrationVIEW too in just a moment, but if you're running that particular setup and you're running the 2 outputs in phase, what you would be seeing is this green sine wave, and there's actually a second control accelerometer from the second shaker should be overlaid perfectly. So they're doing the same thing at the same time. If you want to offset them or enter a different phase value, if I was running it 40 degrees out of phase, you'd see this, we'll call it purple line for the second control accel. Green would be the first loop or the first control accel. 90 degrees would be, which one are we talking, this red or maroon line? And if you're running 180 degrees out of phase, it's basically the opposite. So green line would be loop 1, the blue line would be loop 2. And if you want to see that visually, we've got an image here, and this would be your perspective if you're looking straight at 2 shakers. they're in phase. You can see they're at the same position. They're going to be moving up and down at the same time. So they would both hit the top point together and then down, up, down, but they're moving in tandem. And then if we're at 180 degrees out of phase, you've got shaker 1 is at this peak position, shaker 2 is at the bottom, and then they would, in essence, alternate. So if we look at the rocket on here, it would be rocking. So this side is up, this is down, now this is up, this is down, and it would continue to move in that manner. But so, and then like I said, you can enter manually any phase value between 0 and 180 degrees, and we'll show you that in VibrationVIEW. Another setup with this dual axis or multi-loop with phase control would be the push-pull configuration. So this is another setup where I've got a very large fixture. I mount a large product to it, and maybe it's too big to drive with one shaker. So what you do is you mount one shaker here, attach it to the fixture, one shaker here, attach to the fixture, and then you run them 180 degrees out of phase. So they're facing each other, and you want it 180 degrees out of phase. So this one is pulling, or pushing, sorry, this one's pulling, then this one pushes, this one pulls. So they're working in tandem to drive that very heavy fixture, product, or device under test. And yet another unique one. This is from an international customer several years ago, but they had a test article that they wanted to run and basically test with it moving in an oval pattern. So they configured 2 shakers. It did require a customized bearing assembly just to allow this to move in this motion, but you know, for our intents and purposes, it's just setting it up with shaker 1, shaker 2, and they ran them 45 degrees out of phase. So this actual head expander or fixture is going to be moving in an oval pattern. So another kind of unique setup. We've got the link here to the video. So this is going to be the two loops or dual loop random. And you can see those shakers were moving in tandem. So same thing was happening on each one. Mouse is acting up here. Okay. So random. Let's see here. You can see the test running. This video is available on our website too if you want to watch a little bit more. We'll show you the sign portion here too right at the end. So we're running these in phase. When I go into the software, I'll show you how you can adjust that. But you can see that missile is moving in tandem, up, down, on both shaker systems. Great. So let's switch to last slide, I guess, right here. So this will be the setup with the VR10500. What we have is output number 1, sending the signal to this amplifier. That amplifier is going to drive shaker number 1. And then we have a control sensor connected to channel 1. And then output number 2 to the second amplifier, driving the second shaker. And we have a control sensor connected to channel 2. For my example, I'm going to be using different channels, but this would be the basic setup for this type of dual loop vibration test. So into VibrationVIEW, let's bring up the software and I can walk through the setup. All right, so what we have is, this is VibrationVIEW. A couple of housekeeping items here. I'm connected to my VR10500. Inputs, I'm just looping back the controller on itself. But the other piece is the limits. So if you've watched any of our other webinars, we talk about how important it is to set up the shaker limits appropriately. In this case, my example is I have 2 shaker systems. You'll notice we only input 1 shaker limit. We assume you're running the same shaker on identical shakers. Most oftentimes that's how it works. But we do select one, or allow you to select one shaker, and those limits will apply to both loops in this test. So I've just got our VR4600 shaker. That's the one I showed in the video. We'll leave it here for this presentation. So good enough. And then system check does work as well. So if we want to set it up, I've got loop 1. We should see channel 1. Here, let's remove a couple of the channels on this graph. I have loop 1 is controlling on channel 1. Loop 2 is controlling on channel 5. Loop 3 is controlling on channel 9. So we've got loop 1 is good. I can do loop 2. All right. And loop 3. Let's just make sure we're seeing a response here. Beautiful. All right, so I've got my system set up appropriately. Let's double check one thing here a minute. Good to go. All right. So for this first test, what we're going to do is set up a sine test. So new test, sine. And the profile in this case isn't super important. I'm just going to set up a sine sweep from 30 to 1,000 hertz. And we'll just input 100 sweeps just so we let it run for a while. We will not complete that for the webinar. But now I can walk you through the setup. And you'll notice the software is the same as what you're used to for running single axis vibe tests. Having mouse problems here today. All right, there we go. So I'm going into advanced test, and the first thing that I need to do, so by default we're running a single loop or a single output, controlling on channel 1. You can't always adjust that. But what I need to do in this case is enable loop 2. So loop 2, by default we check channel 5, but this could be any other channel. That's going to be my control channel for output number 2. So that's your big step there. You can enable a couple of different control methods. We have by default magnitude and phase. Again, that's only possible on the 10500. Magnitude only, and then we also have equal outputs, and that's essentially doing a T to the drive. So same signals going to each one of those shakers. Got a good document in the help file. If you want any additional information, click help, and we give you definitions for all of those. But just know there's several different control schemes that you can use for these multi-axis tests. So loop 1, loop 2. The requirement for this, the dual loop with phase control, is it's the same profile for each loop. On the lower left of this screen, you can see there's loop 2. That's the profile I'm looking at now. Loop 1, same profile, but I can look at each loop individually. That's going to be the key here. So what's my profile, or what's my schedule? I'm running this 100 times. If I look at loop 2, this is where it gives me the ability to enter a phase value. When we start, I'll just run this test and I'll have the phase be 0. So they'll be doing the same thing to start. And then we'll come in and we'll change this and actually do an offset. And you can see how that works or how it looks. So we'll call it MA Sign Webinar. Oops. So save the profile and hit run. So a couple things that you'll see. I have a demand for each control loop. You'll notice they're the same because they are the same profile. I have the acceleration profile here. Excuse me. If I want to add, so let's go, top graph is acceleration versus frequency, that's fine. Let's say I want to look at the waveform on channel 1, so that's my control channel for loop number 1. I also want to look at the waveform on channel 5, that's my waveform for my second control channel. We're looking to have it in phase, so you'll see basically it looks like one time waveform on this bottom graph, but if I click them, you can see they're overlaying or on top of each other. Let's just pause this a minute. To show that you are actually getting two, or you have two traces there, if you double click one of these channels in the legend, you can use the drop line. And what that's doing is filling in essentially the area under the trace. So channel 5, I'm seeing that. Channel 1 is basically right over top of it. So we do have two time signals there that we are seeing. You can also add multiple graphs, show you how to update that. So if I want to see loop 2, this same graph, and then I hit insert, now I have graph 2, and then I want to see the waveform on channel 5, I can do that. To arrange them nicely, if I hit tile vertical, now I can see loop 1, loop 2, and I could see these two acceleration waveforms, just channel 1, channel 5. Looks great. Let me re-add channel 5 here. Graph traces, so I just right-click the graph and I can do it this way. But then if I hit edit test, go to my schedule. Oh, where's my phase value? Don't see it. Yep, that's on channel 2, so I have to look at my, or loop 2. If we want to do a 45-degree phase, look at the bottom graph. You'll see now we're controlling to 45 degrees. So channel 1, channel 5. I'm going to drag up and release. Oh. All right, mouse. So click here, drag it up, and drop it. I apologize here, the mouse here is not working real well. Might have to take my word for it. So what I'm doing is dragging, there we go, and dropping. And I'll just call this one 45. So I made a static trace, but just to show you, we're basically duplicating the graph that we did or looked at in the slides. All right, so if we hit OK, all right, now let's say I want to do 90, hit apply, watch that bottom graph. So there we go, now we're controlling to a 90-degree phase value. Drag it. All right, this is going to be the last one I do here. The mouse is just super laggy, so my apologies there. But 90, and then we can do this too. If we go 180 degrees, it'll basically be inverted. So this would be our configuration if you have that push-pull setup. So one shaker is pushing, the other one is pulling. You want it to be 180 degrees out of excuse me, out of phase. So I have 1 and 180. It's exactly the opposite. But you can do these changes on the fly. Right now I'm at 145 degrees, running my 2 shakers 180 degrees out of phase. So biggest thing there, we want to make sure we're enabling loop 2. We're choosing the appropriate control channel, and then also system limits. And then for our schedule, you have the ability to enter the phase value when you're looking at loop 2. You don't have that phase option in random or shock. It is available in sine. So first example, dual loop, multi-loop with phase control. We have some additional information in those slides. You can download a copy of them if you want to follow along or see some additional info. But that is the first example. So I've got some screenshots there. Second example, this would be the, we'll call it more traditional 3-axis, or what you probably think of when you hear 3-axis vibration testing. So 3-axis simultaneously, I have in this case 1 shaker driving vertically, and then the other 2 are driving in the X and Y axes. So the key to these setups too is going to be the head expander, like bearing assembly, because you have to allow for motion in all 3 of these axes at the same time. That is a bit of a science, not the purpose of this presentation either. Some of the shaker guys could probably talk to you for a very long time on how you tune a shaker like this, or some of the mechanics involved. But for us, we're just sticking to the control. But yeah, this is what we're talking about in this case, 3 axes simultaneously. For this application, we can run different profiles for each axis. So I can run 1 profile in Z, 1 in X, 1 in Y. They do not have to be the same. But the key is to minimize the effect that, let's say, driving in the Z axis has on the Y axis or on the X axis, and then vice versa. You want to minimize the effect that driving it in this axis has on the other 2. And that is the key to a system like this, and that's what makes it very, very difficult. But yeah, so for this type of application, typical use cases, random, FDR, so field data replication or running time histories, and then earthquake, pyroshock. Typically that is, so SRS or UDT, we call user-defined transient. The setup for the seismic system or the tripod is very similar to what I'm showing you here, aside from 1 additional entry field, and I'll talk about that briefly next. So, 1 specific 3-axis specification, Mill Standard 810H, method 527. So it calls for multi-exciter testing or multiple axis MIMA. Includes time histories, random, also recording. A recorder view is what we call that. Setup in VibrationVIEW is with the 10500. You've got 3 outputs, so let's call it Z, X, Y. And then we enter specific profiles for each axis, and again, pick a control channel for each output. And this is something like we can expect to see. We will set this up within VibrationVIEW now. All right, so let's stop this sine test here a minute and go into new test and random. Setup is pretty similar between this test mode and sine as far as the loops. I mentioned this is a 3-loop or a multi-axis random test. To set that one up, we'll go in, hit advanced again, and then go to the channels tab. So same process. Oh, I am going to change one thing that you'd probably find useful in this test mode. Let's just hit enable loop 2 and enable loop 3. Testing my patience here. All right, there we go. So enable loop 2, enable loop 3. I'm just going to hit OK, and I'll come right back to it. But I want to make this a little bit easier to understand. So multi-axis random webinar. Good. So you can change the names of these loops or of these outputs. And if I go to config and outputs, okay, you can edit the name. So if I say z-axis, x-axis, y-axis, we'll now see this as opposed to loop 1, loop 2, loop 3. That makes a little bit more sense in your dual loop, or that first example we talked about. But so from here, advanced, go in and go to the channels tab again. I've enabled loop 2, or sorry, Z, X, Y, and same process here. So my Z-axis, channel 1 is used for control, my X-axis, channel 5, and my Y is channel 9. And I have 3 B and C cables looped, so from drive output 1 to channel 1, 2 to channel 5, 3 to channel 9. And then we have a couple different control options here for 3-axis or multi-axis random. Equal outputs, again, is basically T in the output, and then magnitude control only, magnitude and phase, and then uncorrelated is independent. That's what it used to be called in the older versions of software. And then from here, same process as you're used to for running a single axis random test, or is pretty similar to what I just showed you. We have the ability to enter profiles, and I mentioned these can be different for different axes too. I had a profile saved in Excel here, so I'll just show you a couple unique things. Come on. So I have a profile in Excel. We can copy and paste profiles from Excel into VibrationVIEW. There we are. So if this is my profile, let's say for the Z-axis, I can copy and let's just do it this way. All right, and then go into VibrationVIEW, and if I hit paste, I can paste that profile right in for my Z-axis. Let's do the same thing here for my X. Now I'll go to my X-axis in VibrationVIEW. Okay. We're getting there. All right, X. Right click and I can paste that breakpoint table. And then we have Y. So going down to Y. And then rather than just taking the breakpoint table I have from Excel, another thing that you can do, let's say my Z and Y are the same profile, for example. I can right click in here and just say, okay, paste that table from my Z axis, and here it is. So now I have separate profiles. There's my Z, or my Y, excuse me. There's my Z, which is identical, and then I have my X. So 3 individual profiles, and I am ready to run. So what do I have? Just run for an hour. Beautiful. We're good to go. So I mentioned before too the goal of these tests, or some of the trick of this multi-axis or 3-axis random testing simultaneously. You want to minimize the effects of, so driving in Z, the effects that has on X and Y axes. We can do that with what's called notching. That's a subject for another webinar, but you can basically, you can say, okay, I want to notch a frequency that is impacting the other axes. I want to notch it in the Z-axis to minimize the effects of X and Y, and you would do that on the notching tab. Again, basic webinar here today to go through the functionality, but that is another feature if you're running this type of test that would probably be useful to learn a little bit more about. All right, so I have my acceleration, so the PSD graph, and then I have the drive signal for Z. If I want to add a new graph, let's do my X. Same graphs. And then I think I was doing the output drive. Good, good. And then I'm also going to do the output drive, well, the Y-axis and the output drive for that same axis. Tile vertically. Now I can see 1, 2, 3, or Z, X, and Y. I hit run, and we'll see each of these 3 axes coming up to level. You can also get a quick snapshot to the left, so my demand, and then what is the control. And we're bringing these into tolerance. So again, controlling all 3 axes, we got Z, X, Y. Let me take a look here, make sure I got the right channels. So Z should be channel 1 for control, control, control. Get rid of you. All right. So it looks like I got channel 2, channel 3, or Z is good, X and Y. What do I have here? It looks like I screwed up test entry here. Good. Good, good. I should have double checked the profiles that I put in here, but we're still working to get channel 2 or the X and the Y in tolerance. I think I must have screwed up a setting here, but rather than trying to do a deep dive, figure out what it takes to get this thing in tolerance, we can just move on to the next one here, make sure we're Still cruising along. But yeah, big thing for 3-axis random. We've got individual profiles. They can be different. So Z, X, Y. You've got your schedule. Same here. And then choosing the appropriate control channels. So for loop or axis Z, axis X, axis Y, you'll have an individual control channel for each shaker or each output. Good. All right. So third one is going to be, again, we call this multi-loop. This would be, if you think of like a 4-poster, if you've seen one of these in the past, think of it as one actuator or one loop, another actuator, another loop. We've got one loop or one actuator on each wheel in this example. We'll play through this briefly, but what we did is recorded time histories, and we had accelerometers on each wheel. And then what we're doing is replaying a time history file to each actuator. So if you think of it as, in this example, a vehicle, if it was driving over a speed bump, I would have the recordings started at the same time. If we replayed it on this 4-post system, hit start, you'd see the front wheels go up and over a speed bump with a delay, and then the back wheels would go up and down like it's going over a speed bump. This is typically done in a single axis. So in this example, it's like a 4-post system. I've got 1, 2, 3, 4, but it can be 2, it can be 3, or it can be 4, and they can also be in different axes. They don't have to be only vertical, for example. But you can run the same profile or different profiles per loop. And then so random shock, FDR, the phase output drive files are synchronized between the outputs for shock and FDR. So I hit run, it's going to start all 4 of those at the same time. So that speed bump example, you would see 4, or the front 2 wheels going over and then the back 2 wheels. Setup for this, so is not a whole lot different. Again, same process. There are a couple gotchas that I'll show you quickly. And I only have 3 outputs set up, so we'll do a tricycle 3-post system. But what you do, you go in here, and I have a file. Where did I save it? Saved it in here. So I've got a file that has 4 time history files. So let's say for this example, that's the front wheel of the tricycle. This is back left. This is back right. 4th one we'll pretend isn't there. But what I've done is I brought in the file. I'm going to go to my channels tab again and enable these. I'm going to hit OK, FDR webinar. I'm going to rechange those names too, just because it makes a little bit more sense if we're talking a 3-poster. So we'll say loop 1 again, loop 2, and loop 3 as opposed to X, Y, and Z. But channels, so we go in, we have to again enable loop 1, choose my control channel, so this is channel 5, loop 3, channel 9. I have those set up appropriately. Once these loops are enabled, we can go to the playback tab and now choose what channel we want for each loop. So I mentioned I've got 4 channels. We just selected the demand channel for this loop. So loop 1 will be channel 1. If I go to loop 2, I will look at this, so channel 2 from my time history. And then I go to loop 3, and I want that to be channel 3 from my time history. So loop 3, loop 2 you'll see, and then loop 1 is channel 1. So those are all set up properly. They're ready to go. And now I can just hit OK. and I'm ready to run. So we'll again add, I have loop 1. Let's do, I want to look at loop 2 versus frequency. Oh, whoops. New graph. So I want loop 2. It should be what channel? Well, I got control on there. And then let's do our waveform for loop 2. And we'll do the same thing for loop 3. So I want that and that. And then tile vertical again. And I'm ready to go. So loop 1, loop 2, loop 3. Within the last version or two of software, we also included the time history, basically the whole graph view. So now we can see where we're at in this time history file. Older versions of software, you were limited to this small time window. So in this case, 200 milliseconds, you couldn't see exactly where you were. But we are controlling each of these 3 loops independently. You can see how we're doing, along with the time waveform, and then where are we at. You do have the same filter ability here, or the notching ability, as you have in single axis FDR. So if we're on loop 1, this waveform, you can apply a notch live. Let's say we want to notch out 100 to 300 hertz. You can see what happens right here on this waveform. We'll be notching out 100 to 300, and again, you can do this live. Yeah, so our tricycle 3-post system running a time history file using field data replication. Same process, enable the channel or enable the loops, choose the control channel. The big thing in FDR is you have to have the individual channels in the same time history, and then select your demand channel on each control loop. So any questions, feel free to type them in the comment bar. We will address them. But with that, we are on to the last multi-axis control. And this one is going to be brief. This is a seismic system or earthquake or a tripod, a lot of different terms for the same type of test. But we've got a couple examples. So this is going to be, it's a control panel for a nuclear facility or a display. You'll notice it is 3-axis simultaneously. In the past, we had a separate hardware unit called the GeoBox that did the table geometry calculations. We've integrated that into the 10500, so you don't need that GeoBox anymore. But we can control 3 axes. Typically, these tables are designed to test in 3 axes, so X, Y, Z, and can constrain the pitch, roll, and yaw directions. But that's pretty extreme. This is a little more subdued test, but same concept. And we have the ability to enter either a linear or rotary seismic system or a tripod system. So another example here. Typical use cases, IEEE earthquake tests. But yeah, like I said here, typically set up to constrain the pitch, roll, and yaw. Transient software, UDT is what we call it, user-defined transient, plus the IEEE package would be required. You can do this with a single 10.5 now, and then sine, random, FDR are also available. One output can be used to drive either the X, Y, or Z alone. So you can swap drive cables and say, okay, I just want to run, Z sine, X sine, Y sine. You're swapping the drive cable. You can do that with one instance of the software. The only addition to run a tripod system is it's under the global configurations, and then you have a this I think was my mistake for my 3-axis random. I had the tripod output selected, so I think that was screwing me up. I was going over the webinar yesterday, and forgot to disable this. But you go to this tripod field here, and then you can select, so disabled is what I should have had. You can select either a linear or a rotary system, and then you enter the parameters of your system. So you've got base angle, base and table radius, leg length, actuator length, table height. So you enter these. That allows us to do the table geometry, and then you will also enable the tripod limits. And then from here, so you've got acceleration, velocity, displacement, enter those. And then the process is the exact same as what we did for the simultaneous 3-axis. So for SRS, this is a lot of the earthquake testing. You do the same process of enable your channels. You calculate or enter your breakpoints, set up the waveform for loop 1. Same process here. Let's do loop 2. Synthesize, iterate. So again, setting up your waveform. Same process for schedule. How many pulses do you want to run? And then again, hit run. These will all run in tandem. So I hit run once. We output loop 1, loop 2, loop 3, or X, Y, Z at the same time. So with that, we are just about to our hour. If anyone has any questions, again, feel free to type those into the comment bar. If not, hopefully everyone learned a little bit more about 3-axis testing and some of the capabilities that VR offers. My name's Kevin Van Popering, and feel free to reach out and hopefully talk to you soon. Thanks.